Hello and welcome back again. Today, I'm going to share some new lecture with you with 10.5, talking about absolute converge and absolute diverge, and also we see absolute converge. As well, we have a ratio and root test. So today, I'm going to cover three things. Actually, in the Thomas 12, these ratio and root tests, they are 10.5, and absolute convergence is in 10.6, but here they updated like that. So it doesn't make a change, it's the same. Here we have a convergent. You can see from the definition of the convergent, absolute converge or converge absolutely. We have a series, for example. So in 10.5, we have absolute converge, okay? As well, we have what? We have root and ratio and root. Ratio test, root test, okay? So root and root, we recall like that to control it. So I'm going to talk about absolute converge, and here's the definition. You can see, here's the definition. A convergent is absolutely converged, where if the corresponding AN is converged. For example, you have a series AN. You don't know about its converge or diverge. Then, after taking absolute value, you recognize, after taking the absolute value, you recognize that one is 100% is converged. You are sure about that. So absolute is for what? Is for converge. Careful. Like entity is just for diverge. That one is just for converge. They don't give you divergence, okay? There's no answer for divergence. So if the condition satisfied, if we took an absolute value and we go to what? 100%, you go to converge series, then we say the original is also converge. Like what? Like the series, look at here. That series, I don't have any information about it. Why? Because it's equal to what? It's equal to 1 minus 1 over 2, right? Hello? No. If n is 1, you'll get minus, that will be plus 1. So I'll get 1 square, minus 1, 2 square, plus 1, 3 square, and go on. So that one is alternated, positive, negative. And I don't have any idea about its converge or diverge. I don't know. One of them is increase, one of them decrease. So in that case, I see if this is AN, and I don't have any information about it, but if I take absolute value, I'll get what? Am I right? Clear? Then after, hello? After the absolute value, I'll get what? These minus will remove, right? If you take an absolute value for here, you will get 1. If I take absolute value for the second term, I will get what? If I get that one, so all negative part removed, right? Am I right? Good. All negative terms, parts removed. So that's why I say if I take that one will remove, and it remains what? 1 over n squared. And 1 over n squared is what? Which type of the series? Converge, but why? Which type of the series? No. 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 Geometric is 2 to power n. Geometric is 2 to power n. This is the reverse of geometric. P series and P is equal to 2. 1 over NP. So P series and P equal to 2 greater than 1. So 100% we are sure about that one is converge. So our series original is also converge. You know why I say is also, right? To think about there's another one, not comparing, another one. So that is also converge. By what? By absolutely series. Sorry, absolute test. So here we are. If we take absolute value, we get a convergence series, then we say the original one is converged. But careful, not. If I have this series, which I don't know about it, and if I took a absolute value, absolute test, if I have something like that, so I say what? I'll get what? Am I right? And that one is what? Harmony. And is what harmonic? Converge or diverge? Diverge. So you cannot say that one is also diverge. Why? Because absolute value test is for what? For convergence. Understood? You got it, Jamaat? Guys, do you understand? So I cannot use this test for that example because after that, absolute value I should have. It must be convergence one. If there's a divergence, so it means that your test is not good. Go use another one. Understood? That's not about the first part. Do you have any question? If that one, then that one. If that one converge, if condition, the result should be converged, then we can say that. Good. So here we are. And that's a very important example, sine n over n squares. Actually, it's like a irregular one. So we have sine n over n squared. Yes. If you open the term, when I say open, I mean expanding the term. I'll get what? From n from 1. Yalla. I'll get what? The term is like what? Okay. If n is 1, I will get what? Sine of 1, right? Okay. If I say 2, I'll get what? Do you think there's a negative value here? Do you think we will get negative value there? Really? Yes? Where is yes? Okay. Okay. So give me one of them, one of the negative, just one term. Two pi is equal to 0. You are close. 3 pi over 4 rest, right? 3 pi over 4. How? Look, sine is positive from 0 to pi over 2. Am I right? Right? And how about till pi? This is positive, right? So I'll get what? For example, sine of 0, I'll get 0. Sine of 1 is positive. I don't know is equal to, but it's positive. I'm sure about that. Sine of 2, sine of 3, sine of what? Till what? Till sine of is positive, right? But sine of 180 is equal to 0. You are right. Is equal to 0, right? Then later I'll. And after that one, so plus 181 over 181 squared. I'm sure about that one is negative. Why? Till where? Huh? Till 359. You know why? Then at 60, oh, sorry, 360, I'll get 0. And then positive, and then negative 0. Am I right? Like that. Because here's 0, here's positive, here's negative, again 0, positive, negative, positive, negative. So we had, or sorry, we have negative term. Am I right? You are sure about that one. So that one will be 0. All these package will be positive. All these package will be negative. That one again 0, then positive, then 0, then negative, then 0, and go on. You are sure about that, right? Now it's clear. Understood? If I put, for example, sine of 3 pi over 2, I know I'll get minus what? Minus 1. So minus 1 over 300 like that. So we will get positive, negative part. So I cannot say that one is increase and that one's decrease, right? Sign is increase and the other sign is decrease. So we cannot decide. But if I use absolute value, I'll get what? Am I right? Why? Because I know sine of n between 1 and minus 1. Am I right? When I put the absolute value, that one will be 0 and 1 again, right? So I got what? That's why I wrote 1 here. Understood? Maybe you ask, why we don't put minus 1? Because we took our absolute value. And the absolute value make the sign. When we took absolute value, it will make it like that. The graph will be like that. You got it? That negative part will reverse to the up, to positive part. That's why, even you don't understand, you know about sine of n between 1 and minus 1. Here we are. We took a minus absolute value and we got the positive part. So that's why we got that series. And that series is what? P series. P equal to 2 greater than 1. Converge. Am I right? So I can say that this series is absolutely converge. We took absolute value, we got converge series, then we can say that. Understood? Any comment? What actually is irregular one. You never see something like that. So mostly they have a minus, but that one is, you should think more. So don't worry. If you saw something like that, you can deal with it like that. Okay. We see that we have absolute test and we have ratio test, right? So then we have a root test. So that one done, we are going to talk about that one. Any question about the first part in 10.5? Good. And there are actually 3 of them, they are very important because some of them we cannot solve, some of the series we cannot solve by the previous one. Good. So what's a ratio test? In the ratio test, we have rho, this symbol, and this symbol is a reverse to P series. You should be careful. And he say what? You have an, you don't know about it. You make a ratio and you get the result, row. And depending on row, we decide. So I have an, I don't know about it. From that one, I am going to make a limit. An plus 1 means that each n make it plus 1 and over n, and I'll get row. And that row has three cases. Maybe row greater than 1, maybe row less than 1, maybe row equal to 1. If it's a greater than 1, I told you it's reverse to what? To PCS, so it's diverge. If it's a smaller than 1 row, it's converge. Okay, Kaka? Okay, good. If it's equal to 1, this test is not working. We should use another one. We should find another test. Like entity. Entity sometimes is not working, right? We use P series. We use limit comparison. That was, again, the same thing. I know it's not easy at the beginning to get it. What's an? What's n plus 1? And the proof does not include. Now I'm going to the example, and I'll let you know about that. So here we are. We have 2n plus 5 over 3n. You can solve that one by geometric series as well. But here, I'm going to use another test. Understood? To get the idea of ratio test. So you can solve that one by 10.2 geometric series. Try it at home. Now by ratio test, we say what? That one is an. We say limit of n approach to infinity, an over an, sorry, an plus 1 over an is equal to rho. So now limit of n approach to infinity. Where's an? I know an is like that. 2n plus 5 over 3n is mine, right? This is my question. So where's an plus 1? Look at it. Look. 3, 2, 5. So n plus 1, n plus 1. And instead of each n, put n plus 1. You got it, Kaka? Hello? Good. So I'll get what? How you solve that one? Maybe it's very hard. IC is equal to multiply 2. This is mine. And that one, the new one. Am I right? And I know there's something I can play with it. Like what? 3n, 3n. It remains what? Only 3, right? So I'll get what? Limit of n approach to infinity. 2n plus 1 plus 5 over 3, 2n plus 5. So the derivative is equal, that limit is equal to what? We saw that one actually in this example. Yalla. The result is equal to what? Yalla, think. Tell me something. Come on, guys. You so many times that one. Why 1 over? So what do you mean? You mean the degree is equal? Like that? The degree are equal? What do you mean by that? Y is equal to 1 over 3. It's not square. Just directly tell me the result is what? Equal to what? Directly, if I put infinity. Infinity over is not degree, careful. That one is exponent. Is not n to power 2, it's 2 to power n. So we have infinite over infinite. Am I right? Because 2 to power n is going to infinite that one. So I got what? Indeterminate form, type first type, type 1, I. So how we solve that one? You can use L orbital, or you can use what? How we did in the previous one? You can divide by 2 to power n. Am I right? We can divide by 2 to power n. So I'll get what? You can use L orbital, derivative denominator, derivative denominator. So let me solve by L orbitals. So I'll get what? 1 over 3. Derivative of numerator is equal to what? Itself, right? A ln of the base, derivative of here equal to 1. How about here? Derivative of here 2 ln 2, right? Understood? So that one with that one will be cancelled, and that one with that one will be cancelled, remains 2 over 3. This is the first idea to solve by L orbitals. The second idea, I have what? Limit of n approach to infinity, 2 to power n plus 1 over 5, 1 over 3 let be out, 2 to power n plus 5. So I'm going to divide by 2 to power n. I'll get what? 2 to power n plus 1, 2 to power n, 5 to n, 1 plus 5 to n. Am I right? Understood? When you take a limit, yalla, equal to what? After taking a limit, that one will be 0. That one again will be 0. 1. That one equal to what? Just only 2. So I'll get 2 over 3. Understood? Both of them, they are the same. You can use both idea. So second idea. Okay. Now we see that if you take a limit, I will get rho. So an, it was equal to rho is equal to 2 over 3. So I'm going to compare greater than 1 or less than 1. So it's converge or diverge? Converge. Because we say that rho is not like P, there's something else. So that's why how you got 2 over 3 and it's less than 1 and converge. You got it? Jamaat? You got it? Good. Now, a ratio test mostly use it for what? For this example with the factor, with the factorial. I don't see every time. I see mostly. Use it for what? For those example with factorial. And root test we'll use with that one that we have to power n. Okay? So do not forget about that one. Later we are going to use that one. So the second example, we have what? 2n I n I n I. We have 2n I n I n I. I mean by I mean factorial. So n from 1 to infinity. I know you have no idea about factorial. Do you have any idea about the factorial? Hello? Have you seen that one before? Yes. Where? High school? High school, I think. Right? Of course you have it. You have a probability. In the probability, we have that things. Okay. So I'm going to tell you at the beginning, like the first time you are see that one, okay? This is the first time you see something like that. So factorial is multiplication. How? When I say 0 factorial, I'll get 1. This is the rule. When I say 1 factorial, again is equal to 1, because this is the rule. It's not my, maybe you confused, you say how. We have a function for solving that one. You have a proof. Okay. When I say 2 factorial, kindly listen. The first time, when I say 2 factorial means that 2 multiply 1, and I'll get 2. When I say 3 factorial means that 3, 2, 1 is equal to what? 6. Tell me about 4 factorial. It's equal to? Am I right? Understood, Jamaat? Good. So this is the first. The second, how we make it quick cancellation. What do you mean by quick cancellation? For example, if I have 10 factorial over 8 factorial, I'm not going to expand all terms. Just I say 10, 9, 8 factorial. Am I right? And I have 8 factorial and they remove. You got it or not, Jamaat? We are not going to expand all of them. 10, 9, 8 till 1. And the denominator again, 8, 7, because I know that one is equal to that one. So I'll get what? I'll get 19, for example. Understood, Jamaat? Till we get the numerators term, the same. For example, I have 5 over 6. So how we cancel that one, Jamaat? 6, 5. Clear? Shall I repeat it? Where? Cancellation? Okay. We know when I say 5 factorial over 6 factorial, I know 5 factorial is equal to what? 5, 4, 3, 2, 1. How about 6? 6, 5, 4, 3, 2, 1. I know that one will cancel to each other. So it remains 1 over 6. Instead of that all together, I'm not going to do it one by one. Just I say, I know 6 is greater. We are going to the greater factorial. And the factorial is equal to itself. And 5 and 4. 3. So I'm going to write down like that. And again, we have 5 factorial. And I'll get 1 over 6. Clear for now? A little bit more? Okay. Now, I'm going to change number to n plus 1 factorial. Is equal to what? N? Or let me say n. N factorial. N factorial is equal to what, Jamaat? N is any number in my mind. I say equal to itself. Am I right? Multiply one term less than itself. So n minus 1. Am I right? Think in your mind. You have 5. You say 5, 4. So 5, 4. 1 year. So 3. 1 year. Understood? Clear? Just for generalization. Just for any numbers. Am I right? How about if I have n plus 1? Yalla, tell me. Equal to what? Expand for me. Okay. First itself. Don't forget. First itself. Eduardo. N. Right? Then n minus 1. N minus. And go on. Am I right? Clear? Okay. So how about if I have something like that? Shortly do it for me. I'm going with you step by step. So how we do it? We say which one is greater? N plus 1 is clear. So I say is equal to what? Itself and n factorial, right? Why? Because I'm not going to expand all these together. Clear, Jamaat? Easy? How about if I have 2n plus 2 factorial equal to what? Tell me. يلا itself. Okay. So what do you mean -1? Okay, do I? And go on, right? Okay, now if I have 2n, let me do it here. If I have that one over 2n factorial equal to what? Yalla. Which one is larger? Which one is bigger? Numerator, right? So it's equal to what? I say equal to, we fix that one because it's smaller one. Yes. Do. Do Kana? No. You cannot touch it. Okay, like a function, you cannot touch it. Understood? You should expand it just. إذا كانت شيء numerator itself. Okay. Yes. Now you got the idea. For a number, for n plus 1 to n plus 1, does not make a change. The same. Just -1, -1, -1. Repeat it. Itself, -1, -1, and go on. Understood? Okay. My question, it was like that, if you remembered. Now, and I say use what? Ratio test. Why? Because we have factor, I told you. Mostly, I don't say every time. Okay. So I say equal to an plus 1 over an. Am I right? Was equal to rho. And we are waiting to compare value of rho. Okay, tell me. Limit n approach to infinity. An is like that. Hello, guys, right? How about an plus 1? I say each n plus 1. So I have what? 2n am I right? And sorry. I say n plus 1 factorial. N plus 1 factorial. How about that one? I say 2 multiply n plus 1. Am I right? Instead of each n in an plus 1, we put n plus 1. Hello, guys. Understood? It's easy. Instead of n, write n plus 1. That's it. So how we solve large? You say, oh, we make the mess. No. Just go with it. You see it's easier than the previous one. How? Because I say I'm going to write 2n plus 2 factorial over n plus 1 factorial, n plus 1 factorial. That's the first fraction. Do you have any question? And multiply what? The reverse. Am I right? And I know that one can be expanded. So I'll get what? And you know how. And that one itself, 1. That one again, itself. Am I right? Do you have any question for the first fraction? Hello? We just expand 2n to n, n to n. N plus 1, n factorial. N plus 1, n factorial. So that one, and equal to what? N factorial, 2n factorial. Now you know why we did like that. That one will cancel that one. And that all will remain. It's all factorials removed, disappeared, right? So it remains what? Just only the polynomials. And I'll get what? Am I right? Yalla, the result is equal to what? Quickly tell me. No. Where is the student? Quick, 4. Right? 4. How? You just guessed. Because we multiply, I'll get 4n squared, right? And denominator will be what? n squared. So I'm not going to talk about the other part. I don't care. The highest degree is 4n squared, denominator is n squared. So 4 over 1 is equal to 4. Infinity over infinity, but we have here. So it's equal to 4. So that result is what? Rho. Greater than or less? Kawata diverge. Easier, right? We try to cancel what? We try to cancel the factorial. How? By ratio. Make the ratio. Yes. Because no. Good. Any question? Good. So here's the other example. B, and we got 4, which diverge because greater than 1. Okay. Now I'm not going to solve the third part, that one. Look at here. Here's the example. Again, I'm going to use the ratio. So I'll get what? I'll get, after solving, look, an plus 1 over an, reverse يكردوا أو reverse the so that one directly. Then we'll remove that one with that one. We will get just only 4 over what? Over 4. And it will be what? 1. So in that case, what shall we do? Rho equal to 1. What shall we do? Try another one. So how, which things we should use it? Look at here. Let's converge. Why? Because that one, it remains that one. And so it's converge or diverge. You see what? You see we cannot use NTT again because we have a factorial and we'll get 0. Look at the example kindly. If I use the NTT, I'll get 0. So NTT is not working. Just we put what? We think we see that the denominator, okay, so sorry, the numerator is greater than denominator and is going to infinity and will get diverged. Kindly read here and let me know if you don't understand. Understood? So that one is homework. Any question? Just read it. Question. Hello? Any question, any points? Good, you're done. So